a lot of what geometry is about is proving things about the world. And in order to really prove things about the world, we have to be very careful, very precise, very exact with our language so that we know what we're proving and we know what we're assuming and what type of deductions we are making as we prove things. And so to get some practice being precise and exact with our language, I'm going to go through some exercises from the geometric definitions exercise on Khan Academy. So this first one says, 3 students attempt to define what it means for lines L and M to be perpendicular. Can you match the teacher's comments to the definitions? All right, so it looks like 3 different students attempt definitions of what it means to be perpendicular, and then there's these teachers' comments that we can move around. So we're going to, I guess, pretend that we're the teacher. So Ruby's definition for being perpendicular, L and M, lines L and M, are perpendicular if they never meet. Well, that's not true. In fact, perpendicular lines, for sure, will intersect. So, in fact, they intersect at right angles. So that's not going to be correct. And so, actually, this looks right. Were you thinking of parallel lines? Because that looks like what she was trying to define. If things are on the same plane and they never intersect, then you are talking about parallel lines. I also get Shreya's definition. L and M are perpendicular if they meet at one point and one of the angles at their point of intersection is a right angle. Well, that seems spot on. So let's see. I would say, woohoo, nice work. I couldn't have said it better myself. Now let's just make sure this comment matches for this definition. Abhishek says, L and M are perpendicular if they meet at a single point such that the 2 lines make a T. Well, that's, in a hand-wavy way, kind of right. When you imagine perpendicular lines, you could imagine them kind of forming a cross, or I guess part of, a T would be part of it. But I think this comment is spot on. The teacher's comment, your definition is kind of correct, but it lacks mathematical precision. What does he mean by a T? What does it mean to make a T? Shreya's definition is much more precise. They're perpendicular if they meet at one point, and one of their angles at their point of intersection is a right angle, is a 90-degree angle. Let's check our answer. So let's do a few more of these. This is actually a lot of fun. So once again, we're going to have 3 students attempting to define, but now they're going to define an object called an angle. Can you match the teacher's comments to the definitions? So Ruby, these same 3 students, Ruby says the amount of turn between 2 straight lines that have a common vertex. Well, this is kind of getting there. The definition of an angle, we typically talk about 2 rays with a common vertex. She's talking about 2 lines with a common vertex. And she's talking about the amount of turn. So she's really talking about more of kind of the measure of an angle. So let's see what comment here. So you seem to be getting at the idea of a measure of an angle and not the definition of an angle itself. So this is actually right. I would put this one right here. We just got lucky. This was already aligned. So Shreya's definition, 2 lines that come together. So once again, this is kind of the definition of an angle is 2 rays with a common vertex. So 2 lines that come together, this is just intersecting lines. Now when that happens, you might be forming some angles, but I would just say, were you thinking of intersecting lines? And let's see what Abhishek says. A figure composed of 2 rays sharing a common endpoint. The common endpoint is known as the vertex. Yep, that's a good definition of an angle. So Abhishek got it this time. Let's do another one. So 3 students are now attempting to define what it means for 2 lines to be parallel. So now let's match the teacher's comments. So Daniela says 2 lines are parallel if they are distinct and one can be translated on top of the other. All right. So that actually seems pretty interesting. That's actually not the first way that I would have defined parallel lines. I would have said, hey, if they're on the same plane and they don't intersect, then they are parallel. But this seems pretty good because if you're translating something, you aren't going to rotate it. You're not going to change its direction, I guess one way to think about it. And so if you're translating one, if they're 2 different lines, but you can shift them without changing their direction, which is what translation is all about, on top of each other, that actually feels pretty good. So I'll put that right over there. So Ori says Two lines are parallel if they are close together but don't intersect. So if you're trying to define parallel lines, it doesn't matter if they're close together or not. They just have to be in the same plane and not intersect. They could be very far apart, and they could still be parallel. So this isn't an incorrect statement. You could have two lines that are close together and don't intersect on the same plane, and they are going to be parallel. But this isn't a good definition, because you can also have parallel lines that are far apart. And so, actually, I'd go with this statement right here. Part of your definition is correct, but the other part is not. Parallel lines don't have to be close together. So this isn't a good definition of parallel lines. And let's see, Kaori. Two lines are parallel as long as they aren't perpendicular. Well, that's just not true. Because you can intersect. You can have two lines that intersect at non-right angles, and they're not parallel, and they're also not perpendicular. So this is, sorry, your definition is incorrect. This is actually a lot of fun, pretending to be the teacher. Let's do another one. All right. So 3 students attempt to define what a line segment is. And we have a depiction of a line segment right over here. We have point P, point Q, and the line segment is all the points in between P and Q. So let's match the teacher's comments to the definitions. Ivy's definition: all of the points in line with P and Q extending infinitely in both directions. Well, that would be the definition of a line. That would be the line PQ. That would be if you're extending infinitely in both directions. So I would say, are you thinking of a line instead of a line segment? Ethan's definition: the exact distance from P to Q. Well, that's just that's the length of a line segment. That's not exactly what a line segment is. Let's see, Ibuka's definition: the points P and Q, which are called endpoints, and all of the points in a straight line between points P and Q. Yep, that looks like a good definition for a line segment. And so we can just check our answer. So looking good. Let's do one more of this. I'm just really enjoying pretending to be a teacher. All right. 3 students attempted to define what a circle is. Define what a circle is. Can you match the teacher's comments to the definitions? Duru: the set of all points in a plane that are the same distance away from some given point, which we call the center. That actually seems like a pretty good definition of a circle. So I would, stupendous. Well done. Oliver's definition: the set of all points in 3D space that are the same distance from a center point. Well, if we're talking about 3D space and the set of all points that are equidistant from that point in 3D space, now we're talking about a sphere, not a circle. And so you seem to be confusing a circle with a sphere. And then finally, a perfectly round shape. Well, that's kind of true, but if you're talking about 3 dimensions, you could be talking about a sphere. If you're talking about, if you go beyond 3 dimensions, hypersphere or whatever else. In 2 dimensions, yeah, perfectly round shape. Most people would call it a circle, but that doesn't have a lot of precision to it. It doesn't give us a lot that we can work with from a mathematical point of view. So I would say, actually, what the teacher's saying, your definition needs to be much more precise. Duru's definition is much, much more precise. The set of all points that are equidistant from in a plane that are equidistant away from a given point, which we call the center. So, yep, Carlos could use a little bit more precision. And we're all done.